Okay. Hi, Irvin.
What's up, guys?
Hey.
Okay, so how do we feel about getting it done faster today? Is that a consensus okay with everyone?
Oh, she sent me. Yeah, it was really fast.
Okay, I'll go ahead and hit record. Let's see.
Oh,
What just happened? Okay, there we go. That was working. Okay, so does anyone have any questions, I guess, on the part 2 assignment?
I actually did. I kind of botched up the standard deviation part. Was that like pretty easy for you guys to understand?
Sure.
Was it just like the other standard deviation? Because for some reason this one seemed crazier.
Yeah, it was weird. It was like, what was it? The whatever value it was minus the sum of them all squared times the probability. Is that what it was?
Yeah.
Okay. I think it was just a matter of if you plugged it in wrong like once, you're gonna get completely messed up.
Right.
Oh, okay.
I don't know what you did or put in, but
Yeah, I did something wrong.
I messed it up too, and I had to start over because I put the wrong value in. But I remember that.
Okay. Well, I think okay, as long as we know that it's just different from the other one, that makes me feel a little bit better.
Yeah, this one.
I went through it a couple of times, and it's gradually kind of getting it, but I guess the more you practice it, like it'll click.
Yeah.
Okay, well, that was all the questions I had.
I did have one question, though. I kind of had a hard time trying to define what the discrete random means. What did you guys come up with? Because it's like I've read through the definition a couple times, but I still don't understand what it really means.
Discrete random?
Yeah, the discrete random variable.
What did I put? Hold on, I gotta open it.
Well, I had it says is one which may take on only a countable number of distinct values. So it says I had an example of like number of children in a family. So it's usually a count. It says only a finite number.
Okay, so it's just talking about just a number that you can put to something, basically. That makes sense.
Yeah, I think I wish they would have given us like an example because I know what you mean. The random variable threw me off a little bit too on that question on the prep work. I just put the definition of what it said.
Yeah.
But yeah, it also said I guess the random variable is discrete if the values could be listed. So
Yeah.
time, but. I mean, I'm wondering if maybe this will come up again later and we'll kind of get more in depth into it, but for now, I mean, I didn't see any really like practice with it for this section anyway.
Okay, makes sense.
And there wasn't anything on the homework for this lesson for it. The homework's pretty straightforward.
Yeah.
Awesome.
Okay. Well, should we go for the quiz then?
Yeah, sure.
Okay. It's going to be a fast one.
Hopefully. Well, there's 13 questions, so we'll see. Okay. I can read number 3 if everyone's ready.
Yeah.
Wait, just 1 second.
Okay. Give all your probability answers as decimals. This is just a note, do not give probability answers as percents. So, human blood can be classified into 1 I think it's supposed to be one of 4 basic types of AB and AB. The proportion of people in the population in the United States with each of these blood types is summarized in the following table. So use this data to answer the questions. The blood types and proportions given in the table above define a probability distribution. True, right?
Probability. Oh, wait, do they add up to 1? Because then we'll know.
Let's double check. I think
So
45 is... Yeah,
30, 85, 9, yeah.
96.
It's 101.
Yeah, okay, so then it's true, yeah.
Okay. Sure. Okay.
Okay, I'll read the next one.
Go for it.
What is the probability that a randomly selected person in the United States has type O blood? Round to 2 decimal places. That'd be 0.45, right?
0.25. Wait, that if you select one person, isn't it 1/4?
No, I think it's...
Wait, are we using the chart?
Yeah.
Yeah, so we just used the chart. I think it is 0.45.
Okay.
Yeah.
0.45.
Yeah.
So the next question is pretty easy then.
Or would it be 45%, not necessarily 0.45?
No, because the note says give all your answers as decimals. Don't use percent.
I didn't do that. Okay.
And then so, for number 5, well, I guess is someone going to read that? Or...
Go for it. So it's kind of relating.
Okay, what is the probability that a randomly selected person will not have type O blood? So it's just the opposite of 45. Like, I mean, what would create 1?
So is it 55?
Yeah.
55.
So 0.55.
Mm-hmm.
Okay.
I can read the next one.
Go for it.
All right. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowels containing urine were lined up in random order. 6 of the samples were from patients who did not have bladder cancer. Those came from a person identified as the bladder cancer patient. Answer the following questions. If the dogs guessed at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round answer to 3 decimal places.
So it's 1 out of 7.
6.
1 out of 7. Because there's 7 options.
Is it 7 samples?
Yeah.
I got 0.142.
Yeah, that's what I got.
Okay.
Or would it be 0.143?
Yeah,
It'd be 1/4 because 2 doesn't round to the next one.
But it says round to 3 decimals.
Oh, it's 3? Oh, it does. Okay. Glad you said something. So what? 143.
Yeah.
Okay, perfect.
Miranda,
yeah. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? There is little evidence that dogs can detect bladder cancer. This provides strong evidence that dogs can detect bladder cancer. I guess the second one, right?
Yeah, it's about 41%.
Yeah.
So that's pretty high, right?
Wasn't there something in the lesson that said less than, maybe not. Hold on, maybe I just made that up.
Are we allowed to check?
I don't know.
Check the book?
I don't know either, yeah.
I think
I would think so.
Yeah, because it's a group quiz. I mean, we're not expected to memorize it, are we?
I don't think so.
Let's see.
Because with what you were saying, Kelly, I guess what to finish off that thought, because so you take the 22 and divide it into 54, which gives what gives us 0.41%. But then in the book it says when you're doing probabilities, everything you calculate has to equal to 1. And so because the dogs correctly identified 22, and that gives us 41%, then that would kind of show that the dogs also got 59% of the trials wrong, which is a lot more than 41%.
So would it be little evidence?
Hold on. Because I don't know. That's still pretty high because... Wait, okay. The probability that they would get it right, if it was random, is way lower, though.
Right, because isn't that what we just calculated, like up at the top there?
Yeah.
Something,
yeah, you're right.
I think it provides strong evidence because they're way beating the odds, right?
Yeah.
Is there a calculation we're supposed to do to make sure that they're beating the odds, like the null hypothesis or something?
I don't remember reading anything about that, but I think you're right that because the random, like if they just guessed it at random, it's a 14% because they guessed it.
Right.
That many.
Okay, I don't know. Maybe we can come back to it, too.
Yeah, we'll come back to that one.
Okay,
I'll read the next one. M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. If you reach into the bag of plain M&Ms, what is the probability of drawing a red-colored candy?
0.13, right?
Yeah.
Green is scribbled out. Okay, hold on. Let me pull out my calculator.
I got 0.16.
Yeah, that's what I got too.
For green.
Yeah.
Yeah, that's what I got.
Okay. And then...
Is it 1.6 or 1.7?
It should be 1.6 because it's the 2 decimals.
Yeah. And then it's 0.84 for the next one, am I right?
Yeah. Man, we are flying through this quiz.
Yay!
Last section. Want to read this one, Irvin?
Sure. Okay, the ACT scores of students admitted to a medium-sized public university in the Western United States was taken from Capix.com. The following summary statistics were calculated. Use the information from the public university to answer the following questions. Half of the observations are less than or equal to what number?
Ooh.
Whoa. Okay, half of the observations are less than or equal to what number? So the median, we would look at the median. No, we would look at the second quartile, or like the 50% mark. So half are less than or equal to. So
I think that is the median.
Hey, yeah, I think that is.
Yeah, because the second quartile is the median.
Okay, so half the observations are less than or equal to 24.
Yeah, that we wouldn't have to do that in a decimal, right?
I don't see that we need to. They probably would have told us if we needed to.
Yeah.
Okay, so just 24.
Okay. So, wait, is it my turn to read? I can read.
It's up to you. Go for it.
Okay. Based on the information on the table above, the top 25 of the students scored above what number? Top 25. So that's the third quartile. Above the third quartile, so that'd be 27.
Okay, wait. Say that to me again. So the top 25. Okay, that makes sense.
Yeah, so the top 25 are above 75%, and the 75% is represented by quartile 3.
Gotcha.
Okay.
Okay. Which of the following statements is not one of the 3 rules of probability? Probability of the outcome. Okay. I think it's
The top one.
if the probability is high, then the probability is positive.
Yeah.
Yeah.
Because there's no such thing as a negative probability.
Right.
Right. Okay. So then let's go back quickly to this one, the dogs. So, provide strong evidence that dogs can detect bladder. Let's see. Sorry. I'm trying to think. Let's see. I mean, maybe we can use the probability.
I think it's the top one, but you guys,
what's your top one?
Or there's little evidence that dogs detect bladder cancer.
Okay.
Because in the question at the top, it talks about 1 out of 7 has the cancer, and the chances of that dog picking the right one is only 14.3%. And that's not a very confident number, and to tell people that, oh, these dogs can detect bladder cancer.
Well, I think that's why they can, is because there's such a low chance that they would just randomly pick that. It's like 14%. So the fact that it's 22 out of 54, which is way higher than 14%.
Yeah, that's like 50.
It provides strong evidence, because that's way higher than the 14%.
Yeah, but at the same time, doing the math only shows that only 41% they're likely to get it right, and then because you have to have a sum of 1, that leaves 59% saying they could get it wrong.
Yeah, but that's 40.
I see.
40%
of
the times they pick the one cancer sample. So that means that 6 other times were split.
Yeah.
I think also, like, wait, let me see here. Hold on, let me gather my thoughts.
Because then you're still splitting, like, you have 7 samples, and if they're picking the one sample 44% of the time, that means the other 6 samples are being split amongst the 50 whatever percent. So each other sample is only getting picked like 10% of the time or whatever.
Yeah, that's true. So they missed it. 32.
I think maybe another way to look at it is, like, I think, like, the probability that the dogs would get it wrong is, like, 86%, but instead of 86% getting it wrong, it was only 50%.
Yeah.
I don't know if that's just another way to look at it, but I don't know if that helps. But
it makes it sound
sound a little easier to figure out.
Yeah.
Man, I don't know.
I think because it's. I mean, I can't find anything that makes it seem like there's like a specific,
Yeah. Like way to decide. Yeah. Is there a formula to figure this out?
No, the only formula they have to give us are the standard deviation, sorry. And
yeah. I don't know. I guess we're just gonna have to jump off a cliff and see if it works out.
Yeah. I mean, either way, if we miss it, we'll get a 92. So.
Yeah, I feel most comfortable going with the strong evidence that dogs can detect bladder cancer. So I think I'll go with that one.
Yeah, that's what I think.
Okay. Let's do it.
Are we submitting?
Yay!
Yay! Yay!
Wonderful!
Okay, that was like the fastest group meeting we've ever had.
Yeah, nice.
You guys are the best.
Yay, we have the best team ever.
Okay, I'll go ahead and submit this video, and then we'll be done until Thursday or Wednesday. Just, yeah. I'll shoot a text on Wednesday and just let me know which day works better. So.
Okay.
Sounds good.
Thanks, guys.
Good night.
Bye.
Bye.